Hello friends, my name is AJ and welcome to my channel. This is going to be the second video for AP Computer Science. This is going to be a full in-depth review on Unit 2 using objects. Now this video is going to be split up into 3 different parts. The last video was one part and it was 1 hour and 7 minutes long. So I'm going to try to cut this one a little bit so that it's a little bit easier to digest each section, and it kind of makes each thing just a little bit smaller, and each video will be on a specific part. So video 1 is going to be on using objects and what an object is. The second video is going to be on the string and math class, and the third video is going to be the answers to a practice test that I've linked in the description below. I've fully made that practice test by myself. It's 20 questions and a free response. So that is meant to help you kind of prepare and also practice for Unit 2. And I'll be going over the full in-depth kind of the answers and the free response and what you should be thinking for each question. All of that will be in part 3. But without further ado, let's get started for part 1. All right. So the first thing is that when we're talking about Java, right? Java is what is known as, and you may have heard this in Unit 1 as well. This is kind of the most important point about Java and kind of all the points about Java. If you're asked this, do not get this wrong. This is kind of the main thing that you have to know. So even if you get everything else wrong, this is the one thing that you should get right and at least get out of this unit. So Java is known as an object-oriented programming language. Now, what does this mean? This means that everything about Java, pretty much when a program is run, it always has to deal with objects. Objects are a central theme. They're so important to Java that the entire programming language is oriented around that. So that being said, what actually is an object then? If everything is if objects are so important to Java and Java is fully oriented around it, what is an object? So an object, right? Objects are a singular entity. They are a singular entity, almost like a tangible entity. They're one single thing. And they're a single entity that do the actual work. So that do the actual work. And it's kind of interesting when I say actual work, and I'm going to be explaining what that means in a second. But it does the actual work in an object-oriented program. And because Java is an object-oriented programming language, it will do the actual work in your programs. Now, when I'm talking about an object, right, if you think about in the real world, right, an object, such as this one. This is a model taxi car. It's a single object, right? I can hold it. It has some physical properties. It has actions that it can do. This is a very good representation of a real life object. So if you look here I have a little rectangular prism here. And basically this is going to represent an object. And I'm going to use this to represent an object in Java. But when I talk about an object, there are 3 main things that I am looking for. The first thing I'm looking for with an object are the object's physical properties. Physical properties. And we talk about the physical properties of objects in Swift. These are called fields. Okay, fields describe physical properties of an object, right? What an object knows, what an object is like. It describes an object. So let me use this model car again as an example, or this model taxi, right? What are some physical properties that we can, get out of this taxi? Well, the first thing, and the first most obvious thing, is its color, right? The taxi is a yellow color. And another thing, right? The license plate. I don't think it's going to focus that well, but the license plate of this car is, what is it? 7C43, right? That's the license plate of the car. Another thing is the actual location of this taxi car. So you can see over here that this is a New York City taxi. Another thing that you may be able to get out of this is if I just open the door of this slightly and kind of point the camera in there, you can see that it is a 4-seater taxi. So the maximum number of passengers are 4 passengers. So these are all different things that we can describe the object as. So when we're talking about an object in Java, right, we describe these physical properties that the object may have using something called fields. Now, in addition to physical properties, objects can also perform actions, right? So the second thing we're going to be talking about are actions that they can perform, right? Actions that the objects can perform. And we call these in Java methods. You may also hear them referred to as functions, but for the case of objects, we're going to be calling them methods. Methods describe actions that the object itself can perform. So for example, if I talk about my car again, an action that this car may be able to do is drive forward, right? That's an action that the car can do. Another thing is it can back up, right? Maybe another thing the object can do is to open the door of the car, right? Open the trunk of the car. These are all actions that this taxi can do. Another thing, maybe it can turn on its headlights, right? Or turn on the taxi lights or the brake lights, right? These are all physical actions that this can do. So in Java, we refer to actions that the object can perform as methods. Now, the last thing we want to talk about when it comes to objects are how they are actually created. So how they are created. And objects are created using constructors, right? Constructors actually create and kind of set the object. So again, using this model car, it's a perfect example actually of an object, right? If it comes out of a factory, maybe a toy factory or whatever, this is a die-cast car. It's probably just made out of plastic, right? It has no color, anything. It's literally just a blank canvas, right? And so the constructor is actually going to specify, it's going to initially set a lot of our beginning physical properties. For example, it's going to physically set the color, right? I can tell the constructor, do I want my taxi to be white? Do I want my taxi to be yellow, as in this case? Do I want my taxi to be something else, like green, right? I can also specify the license plate, if I want a specific license plate for my car, or the specific location, right, of my car, or something like that, maybe specific tire, something, right? Number of passengers. These are all things that I can specify to the constructor, and then that constructor will set these initial physical properties for the object that I am creating. And so in Java, when we're creating an object, that is known as a constructor. Okay? Now the next thing is I'm going to show some examples, right? So I'm going to show this physical taxi in Java. So I'm first going to show you the example of a field. Okay, field. Now I'm going to use an object called my taxi. Again, it's using camel case, and it's pretty much set as a variable, but this is my object, okay? How the object actually got there, I will get to in a second, but this is a physical, the physical object. Now to access fields, again, these are physical properties of my object. I use the dot operator. It's called the dot operator. It's commonly known in English as a period, but in Java, it is a dot operator. So the dot operator and then dot the actual field name, the name of the field. So for example, max num of passengers, right? And then of course, because this is a statement in Java, we end it with a semicolon. And so this is going to return a value to me, right? This is going to be a value, because it is a field. A field describes an object or has, some sort of physical property associated with it. So it's going to give me a value. It's not going to do anything. It's just going to give me a value. And so if I were to do this, my taxi.maximum passengers, and I were to model it off of my model car, it will return the integer 4, right? Or anything like that. It's going to give me a physical value. And again, to do fields, you physically do the object, dot operator, and then the name of the field. Okay? The name of the field. Now, what about for a method? Right? A method. And remember, a method is an action. Right? So to do this, I do something very similar in the sense I do the object name, and then I do the dot operator again. And basically, the dot operator pretty much allows us to access something related to the object, right? So when I do my taxi dot operator, I can choose something that is kind of part of that object, Now let's say the method or the action that I actually want this taxi to do is to drive forward. I can simply write drive forward, right? Now, I have to have open and close parentheses always in a method. And inside of these parentheses, I can put any inputs. Now, this is optional. Inputs are optional, but those parentheses, even if you do not have inputs there, they have to be there. You have to have those parentheses. And then you put a semicolon. Now, you want to think about this kind of as a factory, right? When I'm talking about actions, I could have inputs that are coming in to the action. And I could possibly have outputs, something that returns out of the other end, right? And that is a returning method. So if I have a method that does not output a value or does not return a value, so no value, that's going to be a void function. A void function is a void method, excuse me. So a value, or if there's no value that is returned out of the method, or there's no output, then it is a void function. It does not mean it's useless, definitely not, because it could be changing things internally, right? For example, drive forward could change the position of the car. It's not going to output a new position to me. It's just going to change that intrinsic property, the field, right, that specifies the location of the car. It may change that, but it's not going to output anything, right, because I didn't ask for it to output a value. Now, if I were to have an output, so or, right, and I had an output, this is going to be a returning function, one that returns a value, method, one that returns it. Now, how about when I want to construct or create an object? So this is actually going to be how I create this right here, how I create the object, right? And this is going to be using a constructor. So the first thing I do is I want to put I'm just going to move this up one. I want to actually put the name of the type of object that I want to create. This case, because this is a taxi, I want to create a taxi type. Now, specifying this actual type is very important. That's going to be coming next in just in a few minutes. But what goes here is the type of object that you want to create. And this is always going to be a reference data type. Now, if you remember from Unit 1, a little bit of a recap, right? We had 3 primitive data types. We had Boolean, we had double, and we had integer. And we also had a reference type with string. And if you remember, the primitive types had a lowercase to start with, and string had an uppercase. So all reference types have an uppercase to them. As you can see here, I put the reference type here. Then I put the name of the variable I want to create. So I put the name here. Then I do equals, which is the fancy assignment operator, right? So essentially here, I'm creating a variable, right? Because I have, if you remember that structure, right? You have the data type, name, assignment operator, value, semicolon. So I already have the type, the name, the assignment operator. Now I need to specify the value. And to specify this value, you want to use a special keyword called new. And this new keyword, right? So new keyword, this allows you to create a new object. So now to create an object, you use the object's constructor. So you put the name of the object, open, close parentheses, and you put inputs here, just like that, and then you have a semicolon. All right? So what this does is this returns a newly created object with initialized fields. What this basically means is that those fields, right? Remember, when this thing is out of a factory, it is nothing on it. When I'm constructing it, I'm physically setting the properties of my final output object. And that is what's going to be in these inputs here, right? So let's say I'm constructing my taxi. I can set in my constructor what color I want it, right? What license plate I want, what, how many maximum passengers I want. the city that it operates in. All of those things I can input into that initial constructor, okay? Now, the actual taxi, so this, you want to keep note that this is the same name as the name of the type that I am creating. This is the same as this over here. They are the same thing because I'm constructing an object of that reference type. So therefore, they have to be the same. It's case sensitive. It is perfect. If I had this lowercase t, it would not work. It has to be capitalized. It has to be the exact same. And of course, when we're using reference data types, our standard convention is to use an uppercase in the beginning. All right. So now I want to use an example also. This is going to go back and kind of recapping something from Unit 1 and expanding on it. So remember, when you created a string, you do string, my string equals, and then double quotes, value, right? However, we know that strings are a reference type. So that means that I can use the exact same method up here to create a string as well. So what do? I first do string, right? And this is going to be the reference type. Then the name, which let me just use my string, right? Equals, then I use the keyword new, right? String. And then I can put an input. And the input specifically for the string constructor is the actual string that I want to do. Just like that. And then I can do a semicolon. Now, what's very special about this is I've just created a string object, all right? And what I've done is I've used the string that I want to, the text that I want to go inside my string as my input for my constructor, right? And so this has created a new object, a new string object with the name my string, all right? So strings are objects, because the string is a reference type, therefore it creates an object. When you do this with integer, boolean, or double, using the lowercase version, the primitive type, it does not create an object. It is a primitive value. That is the difference, right? You may have been wondering last unit, well, why does it matter if there's a primitive or a reference type? This is what matters, right? You have a physical string object. And because I have a string object, I can actually access different methods or actions that I can do with the actual string object. And that's going to be covered in part 2 with the string class, all right? But basically, strings are objects like all reference types. And that is really cool. Now, there's another thing that I want to talk about really quickly, which is the concept of static and non-static. So when I have something called static, right? So for example, a static method, I can call it from the class name, or the type of object, right? Which is referred to as class name. And of course, classes I'm going to be talking about in probably just a quick minute, all right? So it's called from the class names. So for example, my example is if I do type.method, right? So I have my physical type name. For example, if I go up here and I have my taxi, I do taxi and then dot, a method for it, such as drive forward. And so this differs from aptly named non-static. And these are called from objects. So non-static methods are called from objects. Now, what does this mean? That means that I have to physically create an object. So I can say, for example, like type name equals new type. Right? Because that is the specification. Then I put my inputs and I have close parentheses. Then I have to use name.method. Right? Meaning that I had to use the physical constructor first. I couldn't just use this type. I had to physically create an object in order to use that method. And so basically there are two things in this unit that we talk about when we're really talking about between static and non-static. And all of this will make sense between static and non-static in the next video and actually show some more examples. However, the math type is more, it has static functions, while the string has non-static. Okay, and again, all of that I'll be getting to the next video, because that's when I really go in depth between the math and the string. All right. Now the next thing I want to talk about is a class. And a class is a blueprint. It is a blueprint used to define a type for objects. So for example, in order to create this physical taxi up here, right, this doesn't come shipped with Java. If I go and get a computer and install Java, it's not going to have this random taxi type, right? I have to physically create that. I have to specify the methods, right? Basically the physical properties that a taxi object is going to keep track of. I have to specify the actual methods, the actions that the taxi object can do. And I can also specify how that physical object, that taxi object, is created. And all of these things are defined in the class, because a class is a blueprint. It is the physical kind of, it is what is used to create and derive derive objects from. Objects are derived from classes, okay? And they are used to define a new type for an object. So for example, let's say I use the class keyword, right? The class keyword to define a new class. Always, the first letter is capital. This does not follow camel case. This is all words are capitalized. That is the standard for reference type, right? When I'm using a class, when I'm creating a class, I'm creating a new reference type. And then I have an open and close pair of curly braces. So you've either heard them curly brackets, curly braces, or just braces. I kind of alternate them as I'm talking, but generally you want to have an open pair and a closed pair. And so these two are linked, meaning that anything between, right, anything between this and the closing pair is going to be code that is used to specify the actual class that I'm creating. So all of this code here is goes toward creating that class. Okay, and if you didn't already know, to create a comment in code, you do 2 forward slashes. Okay. All right. Now, again, this is a very good example here. I kind of have this thing already written out, right? A blueprint is to a house as a class is to an object. This is kind of what do you call these? I forget the actual name for it. It'll come back to me. But a blueprint, right, is what is used to create a house, right? And a class is actually used to create an object. So it has that same relationship there, right? So a blueprint creates a house and a class creates an object. Okay? Now I'm going to show you. Now don't get overwhelmed because this is a bit crazy. Okay? I'm going to show you the actual creation of a class, and we're going to annotate it. Okay? So this right here, in all of its glory, is a class that I've created. This is a taxi class to specify that taxi type, right? And so I have 3 main components to this. I have fields, I have my methods, and then I have my constructor at the bottom. Now, some people do it in the order of fields, constructor, and then methods, but I'm just kind of doing it in the same order that I drew it above on that diagram for you to make it a little bit easier to understand. All right, so we're going to start off a little bit basic here with the first line, right? If we go line by line, it makes it a little bit less overwhelming. So I'm going to zoom it in. You can just avoid everything below just for a quick second. So I first have, right, the word public. And this is a new keyword that you have not used before. Basically, what public means is that it is available outside of the file. It's available outside of the file that it's created for. Public is a necessity so that you can create objects, right, from different, in a different file from the actual class that you have specified. So then I use the class keyword and then taxi, again, capitalized, that is the name of the new reference type that I'm creating. All right, and then I have open and close parentheses. Now this one here matches with this one. So everything between these two parentheses, are actually, all of this has something to do with the class because they're between these two curly braces. Sorry, I think I called them parentheses, curly braces. All right, so now I'm going to zoom in back to a specific part. Now this is going to be the fields. Remember, these are physical, they describe the object, or they have specific properties of the object. And essentially, when I'm creating a field, all I'm doing is I'm creating variables. I'm creating variables when I do this. It's not that, it's not as complicated, okay? This is similar to something that you've already seen, except now we have this new keyword, private, right? The private in front of the data type. And this basically private means that it is not available for use outside of the object. Now, why is private important? It all comes down to security. For example, if I'm going to go back kind of to the example that I talked about earlier. If I'm a person, right, let's say I have a person object and I have a social security number, right, as a field, because it describes, right, it is a descriptor. It is data that is stored inside of that object, right? Do I want someone else to be able to access that social security number, use it, edit it, do whatever they want? No, only the object itself should be able to mess with that, right? And that is what private basically allows it to do. It means that it's not available for anything else except for the object that was created, all right? And then here we have something very standard. We are creating a variable. We have the data type and then the name. But then notice I don't do the second part. I don't do the assignment operator and the value. And so when you don't do that and you just put the actual data type and the name, this leaves the variable uninitialized. Leaves it uninitialized, which basically means there's no initial value for the variable because I did not set one, right? Because I just used I said the data type and then the name. And then because I put that ending semicolon there, it basically saying that I now know a variable exists, but I don't have an initial value for it. And in fact, this is for many different ones. I have one variable here, one variable here, one variable here, and one variable here. Now, I did this a little bit as a trick because sometimes in tests, you may see this where they put a semicolon here. When you have a semicolon in the middle, that really just means that it's a new line, right? This is supposed to be on its very own line. These are two separate statements. They're separated by that semicolon. That's why you actually have semicolons at the end of lines so that, you can do stuff like this. Now, of course, normally you wouldn't be, you'd want it on a separate line, but the reason I did this is two reasons. One, I wanted to show you, and also second, I was running out of space and I didn't want like two lines at the bottom on some random page. Therefore, I got it to all fit on one page by doing it this way. Okay? Great. Now I'm going to talk about methods, and methods are a little bit different. So the first thing is I have the public keyword, which means that it is available for use. And this is important because, for example, if I have a taxi, right, with the method of drive forward, right, I don't want just the taxi to be able to drive forward. There has to be someone else, such as a person object, that's able to actually do the action, right? That's why public is important. Otherwise, it's pretty much useless, right? If you can't do an action, if something else can't do the action, and only the object itself can do the action, then it is a little bit useless, all right? And now I have the next keyword, which is void. And this is the keyword, right, for no return value. Remember how we talked about over here, up here with the method, I had no value return is void, and then an output, which uses return. So I'm using the void keyword to specify that in my function down here, add passengers, there is no return value. It basically means it doesn't tell me, it doesn't give me an output. It only does something, right? It obviously does something, but it doesn't give me an output. And then over here, right, I specify inputs, right? And this is basically, when I'm saying add passengers, I put the data type and then the input that I'm actually putting in, which is a number. So what this does is it simply takes, right, the number of passengers that I have, and then I add, using a compound assignment operator from last unit, I add this number to this variable. And we use this keyword this. This refers to basically a field, right? Refers to this object. So therefore I can do, instead of up here, how I did, the object and then dot to the field, now I can use the this keyword, and this will basically refer to the actual object. So I'm taking this particular field from the current object itself, okay? Now, the next thing I'm going to look at is this next one, public, and now I have the keyword int, okay? So if I don't return, so I'm just going to erase this up here, or actually, I'm just going to move it over because I have to write something above here. So int, right, refers to that if it does not return, so if not return, or if it does return, rather, if it does return, then I specify the type of return. So that's always important. If it's a non-void, method, you have to specify a type that is physically returning. And then here I have the keyword return. And this is the keyword to return a value. But what that means is output. It outputs the value. So if I were to do system.out.println, remember from unit 1, and then inside of those parentheses I put in, my taxi dot current number of passengers, it's going to print out the number of passengers because I'm returning it. The output goes from the object to the system.out.println, and then it prints out that value. All right. And then the last thing is a void. I'm not returning anything. Make and model is the function, right? So then I simply print system.out.println the make, which is a string, plus a space plus the model. So like if it was a Toyota Prius, it would print out Toyota space Prius, just like that. Okay. Now the last piece, so I now talked about the methods, we're 2/3 of the way done, and we now talk about constructor. And again, this part is actually not as bad either, okay? What is a constructor? A constructor creates the class, and the constructor must always have the same name, so always have the same name, as the class. It should always have the same name as my class up here. That is very, very important that it does. And I use the keyword public. The reason I use the keyword public is because if I can't use the constructor outside of itself, it's completely useless, because you cannot construct the object after the object's already created. You need something else somewhere else to actually construct it. That's why it's public. It's available for use by any other object or any other program. So it's always the same name. And then I have inputs. I have 3 inputs, and inputs are separated using commas here. So again, you always do the type of the input and the name, type name, type name, type name. So I have 4 inputs. I have a number, which is an integer. The is a convertible, or is convert, which is a integer. That should not be an integer. That is a Boolean. That is a Boolean for sure. Because if you look up here, my actual type is a Boolean, right? Is convertible, yes or no? That's a binary choice, either true or false. True, it is a convertible. False, it's not. Okay? So that was a little bit of a mistake. That should be Boolean. All right, I'm not sure what happened there. Boolean. And then string, make, which is MK, and then another string, MDL, which stands for model. So then what I do is I initialize, right? I'm setting the initial states of all of my properties. So I say this.num passengers equals num, int.isConvertible equals inConvert, this dot make equals mk, and this dot model equals mdl. So all I'm doing is I'm basically setting the initial states for all of those fields that are a part of my object. All right. Now this is all very, this is really the main part of AP Computer Science. It really has to do with classes, and there's going to be even more crazy stuff coming in like Unit 7 and 8 involving, things called inheritance, polymorphism, all of that. We're really far from that right now. Right now, you're just trying to figure out how to physically create these objects and learning the anatomy of the actual class itself. Now, in the actual practice test that I have in the description below, which I will go over the answers in part 3, I actually have a FRQ that makes you create from scratch an actual class, right? So this entire thing that I wrote up here, where I have taxi from here all the way down, that is what the FRQ tests you on. It's that one thing of, can you create from scratch a class? Now, there is a unit called Unit 5 called writing classes, right? However, for the sake of this particular FRQ, or for the sake of this practice thing I did, I asked you to create a class, because I think that if you're able to create a class, right, you really understand the different parts of a class and how to basically kind of work with them, right? So the multiple choice will kind of go more over the string and math class, which I'm going to be talking about in the next part of this video. How in the FRQ really talks about this main part, okay? And that's pretty much it. That is part 1 for the Unit 2 using objects. This is a little bit more of the abstract thinking that you have to do and really applying your knowledge. And again, if all else fails and you get confused, go back to the beautiful taxi cab, okay? The taxi cab is a perfect representation, right? Remember, fields, physical properties, right? The color, license plate, right? The city. Actions, methods, right, are things that you can do with this. You can move forward, move back, right? Remember, open the door, right? Open the hood. Or constructors, right? How I physically initially set all of the properties of this car. So those are all of the things that are very important. All right, so that is the end of part 1 for Unit 1, creating objects. The actual PDF of these notes is going to be in the description of this video, as well as all of the next parts of the video. And that practice test will also be in the description, even though I will be going over the answers for that in part 3. If you like the video, leave a like and subscribe for more content. And as always, thanks for watching. I'll see you in part 2.